Welcome to another session of the Kubernetes Fundamentals series, only here in CSharpCorner Live. My name is Rodrigo, and today I'm going to talk about namespaces and health checks in Kubernetes. Before we do that, let me do a quick recap about the things that we saw the other day. You might remember the labels and annotations and selectors. Those are quite important in Kubernetes because they allow you to match things, right? For instance, when you create a deployment or you create, say, a service, how in the world the service or the deployment knows what are those pods in the backend that it should manage? So the answer there is the label and the selector, right? The selector says, okay, I want to manage or I want to communicate to all of these pods that have, I don't know, maybe this label, key equals value or something. So that's the way that Kubernetes matches things, okay? So I think this is a very important thing, and it's a very elegant way to solve this communication problem because you need that when you are using some of the objects in Kubernetes, such as deployments and services, right? So labels is this field or element that we can include in the metadata element inside the YAML file, right? In the manifest file. Of course, you can use the imperative way to set your own labels. However, most of the time you want to do this by using your YAML files. So this is the labels field, and inside this labels field, you can include any label that you want. So for instance, I have 3 labels here: environment, tier, and app. Those are fictitious labels that I'm using in this fictitious code that I have here on the screen. And you can use labels for querying. That's actually the difference between labels and annotations. Annotations is just metadata that you want to include in your objects in your cluster for managing or for annotating. I mean, I'm going sideways, right? I'm saying the same thing. However, that's the difference. You don't use annotations for querying your objects. You use labels, okay? So the selectors are these elements that you said for specifying what are those labels that you want to use in that particular object, right? And we have 2 different kind of selectors. We have set-based selectors and equality-based. Set-based and equality-based. So the difference is the operators that you can use for specifying your selectors. For instance, in equality-based selectors, you use equality operators, right? That's why they're named like that. Okay, so you use the equals to or not equals to and so on. In set-based selectors, you use logical operators such as in, not in, exists, doesn't exist, and so on. Okay, so for instance, we have here on the screen this other examples such as kubectl get pods. I'm obtaining all the pods that have the environment label that is not production. Okay, or in the second one, I'm returning all the pods that the environment label has the production or the QA value, right? And some other things that we can do with selectors. Actually, you can use those for specifying and querying your objects, and most of the time we're going to use that in deployments and services and all the objects that support selection of objects, and mainly pods. Okay, so yeah, selectors, labels, and annotations, as I mentioned before, those are just key value pairs to annotate to add some additional metadata in your objects, right? They allow you to attach arbitrary metadata to objects, and the difference between annotations and labels is that annotations are not queryable. That's the difference. And you can use annotations. There are a lengthy list of annotations that Kubernetes suggests to use. However, you can use any kind of annotation, right? That's on you. It depends on your project. It depends on the functionality that you want to express in your own applications. For instance, I have here this phone numbers annotations. As you can see, this is the annotations label, or I mean, the annotations field, right, inside the metadata section in this manifest file. So labels are used to identify and organize objects, while annotations are used to provide additional information about objects. So that's the difference. And we use some other kubectl commands to manage labels and annotations, such as label, kubectl label, and kubectl annotate. You might remember in this other session that we had in the past, when I created a deployment. When you create a deployment and you show the history of deployments by default, they don't have any kind of annotation. They don't have any kind of cause, right? So you cannot know why a rollout was made or a rollback was made. So that's why we use annotations. However, remember, those are not queryable. That's the difference. And today, I'm going to talk about namespaces and health checks. And of course, let's get started with namespaces, okay? So the thing about namespaces is that if you are familiar with namespaces in programming languages, I guess that's the same concept. They allow you to logically group resources. That's what you do in Kubernetes. There's a default namespace that when you deploy a Kubernetes cluster, we have this default namespace that we can use all the time. Actually, in this series, I've been using the default namespace all the time. So let's go back here to the terminal. And I just deployed this Minikube cluster with 3 nodes. Say Minikube, let me see if this is running, because I just executed the command and I didn't test the cluster. So Minikube status to know if this is running. Yes, it's running. So kubectl get nodes. So as you can see, I have 3 nodes. And we have this other object that is the namespace. So the alias is ns, or you can just type namespace or namespaces or ns, okay? Remember that those are aliases that we can use in Kubernetes. So as you can see, I just deployed this Minikube cluster, and all of a sudden, I have those namespaces, right? Default, kube node list, kube public, kube system. What in the world is going on here? So for instance, default is the default namespace, not surprisingly, right? So any kind of object that you deploy and you create in your Kubernetes cluster is gonna be deployed in that particular namespace. For instance, if I go here to my session 7 folder and I create a new pod, let's create a new pod here, new pod.yaml, and let's use this template. I want to use Nginx, and the container port is 80. Actually, I don't mind about that. In this moment, I don't want any kind of resources, so I'm gonna get rid of this. So this is my pod, okay, just for testing purposes. And let's say kubectl apply file new pod.yaml. So this pod was created in the default namespace. So actually, if I say kubectl get pods, I don't see any kind of namespace column here in this query. Let's see if I execute O wide. So there's nothing telling me that this is in the default namespace. However, let's describe pod my app. And as you can see here, this is inside the namespace that is the default namespace, right? This is the name of the namespace that I'm using. I didn't specify anything else. I didn't specify otherwise, okay? So all the time, if you don't specify a namespace, this is gonna be using the default namespace. So namespaces provide scope for names, not surprisingly, and they're similar to namespaces in programming languages. So for instance, you can create this my app pod or my pod, right, inside the default namespace, and you can deploy another pod with the same name because it already exists in that particular namespace, right? However, if you create another namespace, you can create my pod with the same name in another namespace, okay? That's why we say that they provide the scope for names, okay? Those are, that's actually one of the traits of namespaces. There are some basic rules that namespaces follow. The first one is that names of objects must be unique within the namespace, just as I'm telling you right now. So you can create, my pod twice in the same namespace. Of course, you can create my pod in another namespace. However, the namespace should exist beforehand, okay? So you should create namespaces beforehand before using them in your manifest files or in your imperative commands, okay? So the other basic rule is objects in one namespace can access objects in a different one. Yeah, it makes sense, right? So for instance, you can, I don't know, maybe you can create a namespace named backend or blah, 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 microservices or this specific domain for your applications. And you need these other pods, these other services that they need to communicate to these other services or pods that are implemented in other namespace. You can actually do that, okay? You can do that. Number 3, deleting a namespace will delete all child resources. So I guess this is this comes in handy when you want to tear down an entire group of objects. You put those objects in a particular namespace, and then after you use them, you can just delete the namespaces, that namespace, and you're good to go, okay? And finally, a namespace should exist before assigning objects to it. That's actually what I told you before. If you want to use a namespace, it should exist. It's not going to be created dynamically for you, okay? So you should create a namespace beforehand. So what happens with namespaces is that they span it across all the different nodes that constitute the cluster, okay? So for instance, I have this namespace one, and as you can see, I could have different objects in that same namespace, and those objects might be deployed in different nodes, okay? So it doesn't matter if a namespace is grouping all the objects, those objects will be deployed in different nodes that stand still, okay? That's one of the traits that I told you in the first session or second session of this series about how the scheduler in Kubernetes decides to deploy an object in a node. And of course, you can have a number of different namespaces, like namespace 2, namespace 3, or what have you. And this same trait in this same behavior will be the same, okay? You can have different objects in different namespaces, and of course, those objects will be deployed in different nodes of the cluster, okay? Remember, namespaces are just logical groups for isolating objects, for grouping objects all together, okay? So as I mentioned before, there are 4 pre-built namespaces in Kubernetes. I mean, I just deployed this Minikube cluster. Let me go back to the terminal. So as you can see, if I execute get namespaces, all of a sudden I have those 4 namespaces. And of course, the default namespace is the one that I'm using all the time if you don't specify otherwise. And this is the same with any kind of cluster, okay? If you deploy Kubernetes, you're gonna get those different default namespaces and pre-built namespaces, okay? Because default is the same name as the default namespace. So, of course, if you create your own applications or you install additional tools or other components in your cluster, those applications or components can create additional namespaces. And actually, that happens all the time. For instance, if you, I don't know, maybe you enable the Kubernetes dashboard, the dashboard is going to add a new namespace in your Kubernetes cluster because it's going to deploy all the different components and pods and services and all the different things that it needs in that particular namespace. So it makes sense because in that way, applications and components can be sure that there's no noisy neighbor, you know, and I think it's for management purposes and for easily, you know, manage things in your cluster. So, okay, so let me go back here to the terminal. So another flag that you can use when you're querying your objects by using get is namespace. Actually, I think that's the namespace flag. Let's go back here to the help documentation and see if I can find the namespace option. Actually, I think it's -n and then the name of the namespace that you want to use, okay? So it's -n and the name of the namespace. In this way, you are querying only 4 objects in that particular namespace that you're specifying in the flag. Make sense? So that's neat. So let's see what's going on inside the kube system namespace. Oh, there are a lot of different pods that are running in this cluster. I didn't deploy those. Those were deployed and run by Minikube when it created the cluster, right? So for instance, you might remember when I talked about the control plane and we talked about the Kubernetes architecture. So you might remember that we have this etcd database or etcd, whatever you want to call it, etcd, that's the way that I like to pronounce it. etcd is the database. This is a key value database that Kubernetes uses for storing all the data that is receiving from your input, and it stores the state of the cluster. So etcd turns out that it's running inside a pod inside the kube system namespace. That's why when you run and execute kubectl get pods, you cannot see those different pods related to the Kubernetes system, you know? So we can see that we have the etcd minikube component here. I mean, the pod, the API server, and some other things related to this Kubernetes cluster. So this is neat. This is the way that you can use for querying specific namespaces. So let's try to see what's going on with the kube public namespace. It looks like there's nothing there. Maybe if I query for all, let's see if there's something. No. And what happens with kube? No leads, and there are no resources in those other namespaces. Actually, I think the kube system namespace is the most important one when you deploy a freshly created Kubernetes cluster, okay? Anyways, you can use the -n and then the name of the namespace for querying objects in a particular namespace, okay? What are some of the use cases for namespaces? Why it's not a good idea to use the default namespace all the time? Well, because maybe you have this cluster for your organization and you want to get the most out of it. So it makes sense to structure your applications and things with namespaces, right? So for instance, our use case could be to map the organization structure, say team 1, team 2, team 3, sales division, marketing, development. I don't know. Okay, to map your organization structure is one of the use cases that we can use with namespaces. Or development environments, such as development, production, QA, and so on. Customer partitioning. I've seen this in the wild. I've seen this in real world applications. Say Contoso, Northwind Traders, and your own customers can have their own namespace inside your cluster. And finally, applications partitioning, such as the different domains and components that your applications have, such as portal, backend, security, and I don't know, the different domains that your system spans, okay? Sorry about that. I've been coughing since yesterday. Cool. So how in the world we can get all the namespaces? kubectl get ns, get namespaces, or get namespace. That's the command that we can use to get all the namespaces, okay? How we can create a pod in one particular namespace. You can specify the namespace flag and then equals to the name of the namespace. For instance, let's try to run this particular command. Let's try to do this. As you can see, I'm creating this new pod named Nginx, my Nginx, or what have you, right? And then the namespace flag and team1. What's going to happen? Because I don't have a namespace named team1. Remember that I have default kube node list, public and system. So what happens if I execute this? This is going to return an error. And this is expected because the namespace team1 is not available. So I need to create this namespace beforehand, okay? So I'm going to tell you that in a minute, how to create a new namespace, right? And well, this other command is very easy to grasp. Get pods, namespace, team1. That's actually what I did with the -n. This is an alias of the # namespace flag, okay? So another command that we can use that comes in handy when managing namespaces is config set context and the current flag, because in this way you can set the namespace for all the subsequent commands. So you don't have to specify -n, -n, -n all the time. Make sense? So you can specify in your context for kube control, for kubectl, right? You can specify a particular namespace that you want to use for all your different commands. So in this example that I have here on the screen, I'm using the team1 namespace for all subsequent commands. So, okay, that's neat. And how in the world we can create namespaces. So there are two ways, like any other kind of objects in Kubernetes. We have the imperative way and the declarative way, okay? So imperatively, we can use kubectl create namespace, such as, this is very similar to the other create commands that we've seen in the past. Kubectl create namespace, and if you want to use the declarative way, as you can see, the kind of object is namespace. Remember that kind is this field or element inside your YAML file that specifies the kind of object that you want to deploy, right? So namespace is the kind. So let's do that. Kubectl create in the name of the namespace, kubectl. So what happens if I want to use namespace team1? Okay, kubectl create namespace team1. Okay, so as you can see, I created imperatively this namespace, so I can query for all the namespaces. Team1. There's nothing inside team1 yet. Get all namespace team1. I don't have any object inside this namespace. However, if I execute this command that I had before, as you can see, this my Nginx pod was created inside the team1 namespace. So if I execute kubectl get pods in this moment, you can see that I have the my app pod that I created beforehand. This is not the my Nginx pod that I just created. And this is because kubectl get pods is running inside the default namespace, right? So I should change the default namespace by using kubectl config and set context and the command that I showed you before. Or you can use -n and the name of the namespace that you want to query. In this other case, I'm returning my Nginx, which is the only object that I have inside team1, right? So I guess this is a very easy to grasp topic. So what happens if I delete this namespace? You can use kubectl delete namespace and the name of the namespace, which is team1. And of course, all the different objects that are inside the namespaces will be deleted inside this team1 namespace, right? So if I query for all the namespaces, I don't have team1 anymore. So that's the imperative way. Let's go back here and create a new file. Say that I want to create my namespace.yaml, right? And let's type namespace or Kubernetes namespace. No, I don't think. Oh, yeah, this is gonna work. This is great. API version, kind, namespace, metadata, and the name of the namespace. So say team2. As you can see, I'm not using the spec field. This is not required for namespaces. You only need the API version, kind, and metadata. Okay, very easy stuff. So let's go back to the terminal and kubectl apply file my namespace, and I created this namespace. Okay, kubectl get namespace, and as you can see, I have team2. So I can use team2 for deploying my objects. Of course, I need to change my pod.yaml to specify that I want to deploy the new pod in team2. Anyways, very easy stuff, I guess. Kubectl delete namespace team2. So I can do this, or I just can pass the my namespace.yaml file to the delete command. And it's not necessary to specify the name of the namespace. kubectl is going to figure out what object I'm trying to delete and it's going to do that for me. So this is great. This is for structuring your applications and objects, and I think this is a very easy topic to grasp. Now let's talk about health checks. So the thing about applications that are running inside a Kubernetes cluster is that they can go wrong, right? You can deploy your application and maybe one of those pods or microservices or what have you, they can be in a faulty state, and you don't know about that until it's too late. Okay. So we can use health checks to determine the state of a container or pod inside your Kubernetes cluster. Okay. So they allow Kubernetes to monitor the health of your application and determine when to take action. So health checks are great because they can do things for you or wait for things to happen. And because sometimes your applications can be doing something when they start, right? Maybe you are querying this database, maybe you are calculating some things, and maybe your application is not in a ready state. So you should notify Kubernetes about that. And that's another use case for health checks. Actually, we have 3 types of health checks in Kubernetes. The first one is Liveness. It allows you to specify a health check to be performed against a container to determine if it's alive. Okay, this is the first health check that we can use to determine if it's alive. Because again, maybe you deploy your application, maybe you create this deployment, right? And maybe those container images will be downloaded, and maybe your application is behaving correctly, and all of a sudden, the application is not running anymore, or is not responding to requests anymore. So you might use, in that particular case, a Liveness probe to notify Kubernetes, hey, this pod is not behaving correctly. It's not alive. I know that the container has this pod, the pod has this container. However, maybe it's not responding anymore, okay? In that particular case, with the Liveness probe, the container will be restarted if the probe fails. So actually, it's like any kind of probe that we can deploy in our applications. This is very common when you deploy, say, a load balancer in a cloud. You specify a probe to detect if the particular node that is backing the load balancer is alive or not, right? So it's a very similar concept. So in this way, you can Kubernetes can restart the container automatically if the probe fails. So that's the first health check. The second one is readiness. This is a periodic probe of container service readiness. So readiness means that it specifies a health check to be performed against a container to determine if it's ready to receive traffic. Why? Because, again, maybe in your applications you have this, I don't know, this script that you need to run, or this calculation that you need to execute, or this query that is very, very lengthy. So maybe if you do that when you start your container, the container is not ready yet, right? It's not ready yet to receive traffic. That's why we can use this kind of probes to tell Kubernetes, okay, I'm alive, but I'm not ready yet. Okay, that's different. And what happens if this readiness probe fails? Well, the container will be removed from the service endpoints. Remember that services use a backend pool of pods, right, to direct traffic to them. So if a particular pod is not responding because its readiness probe failed, then that particular pod will be removed from that backend pool of the service. Okay, so it's not going to be restarted. That's for liveness probes. Okay, and finally, the third one is startup. Okay, this is used when you want to indicate that the pod has successfully initialized. Very similar to readiness. Okay. Again, if it fails, this pod will be restarted. Very similar to the liveness probe. Okay. So again, this is for maybe you want to use this startup probe for, I don't know, maybe you want to run a script, or you want to execute this particular application, I don't know, then you can use this startup probe. So as you can see here on the slides that I'm using, I have this pod.spec.containers. Blah, blah, blah. Those are the different fields inside the pod specification where you can deploy your probes. So for instance, let's go back here to liveness. Spec containers liveness probe. So I can go back here to the terminal and execute kubectl explain and pod spec containers liveness probe. Okay. So again, explain is the best documentation that you can get for Kubernetes. In this way, you can understand what are those different fields that you can include in your manifest files. Okay. So as you can see, I have different fields that I can use for specifying this liveness probe, such as success threshold, TCP socket, HTTP GET, exec, and so on. Okay. Actually, I have a demo right here, and I'm going to show you right now, that is using this liveness probe, and it's using two different techniques for probing this particular pod, right? The first one is command execution, and the second one is executing a HTTP GET request. So talking about mechanisms or techniques, there are three mechanisms that we can use in probes to understand and to detect if the probes are behaving correctly. So the first one, as I mentioned before, is the command execution. Maybe you want to execute this particular command in order to know if the pod is behaving correctly. The second one is a HTTP GET request. And this is, of course, for maybe you have this container that is using in a web framework or something. Maybe you're using, I don't know, Node.js, or maybe you're using ASP.NET Core. And then you can expose an endpoint in those particular applications so Kubernetes can create this HTTP GET request. It can send this request to that particular endpoint to know if that particular pod is behaving correctly. Make sense? This is a very popular way of detecting if things are behaving correctly. And the third one is a TCP socket, and it's very similar to the previous one. You specify something that you want to send via TCP instead of HTTP, the HTTP protocol. Okay. So as you can see here on the screen, liveness probes, readiness probes, and startup probes those are fields inside the containers field that is inside the spec of a pod, right? So in other words, probes and health checks are related to those containers that are running inside your pods. That's why I executed pod.spec.containers Liveness probe. I passed this structure, this path to explain because Liveness probe or Readiness probe or startup probe, those are part of containers. So as you can see here on the screen, there are a lot of things that are going on here in this demo. The first one is that it's using the BusyBox container image. BusyBox is very helpful container image that we can use in our applications. Actually, I have the official BusyBox container image webpage here on the browser. And as you can see, this is the Swiss Army knife for embedded Linux. It's a very small container image, Linux-based, that has dozens of different tools and applications that we can use to execute things. For instance, it has, I don't know, wget or curl or whatnot. It has dozens and dozens of different applications and commands. So this demo is using BusyBox. And as you can see, this is executing touch. In other words, it's creating a new file and then it's waiting for 30 seconds, okay? And then it's removing the file that was created. So it first creates the file and then it waits for a little bit and then it removes or deletes the file. And then it just waits forever. I mean, for 60 seconds, not forever, right? Sleep 600 is 60 seconds. And 600, it's 600 seconds, okay? Not 60, 600, okay? And then, as you can see here on the Liveness probe field, it's executing this command, which is cat. As you know, cat is used in Linux for returning the contents of a specific file, right? Cat, and then the name of the file. It's supposed to return the contents of that particular file. And of course, if you deleted the file, then it would fail, right? So this is going on here in this demo by using the command execution. And it's doing this after 5 seconds, and then it's doing this each 5 seconds, okay? So as you can see here, there are a lot of things that are happening, right? However, it comes in handy and it's quite interesting. So I'm not going to type this. That's why I created this pod.yaml file already. So I created this file beforehand just to expedite this process. As you can see, I'm creating this my app pod, right? And it's using the BusyBox and all the things that I just described, right? I just pasted the code that that I showed you right here inside the spec, okay? So I can, this is the pod.yaml file. Actually, I deployed this get pods. As you can see, this is running, okay? And this is because I deployed this pod before I started today's session. So let me delete my app pod, okay? So I don't have any more pods. So let's apply file pod.yaml file. And I deployed this pod. So I can execute getPods again. And if I kubectl describe pod, and this is running, right? Remember that it waits for 30 seconds before deleting the file, right? So it's probing that everything is behaving correctly. That's why this application is running correctly, right? However, after 30 seconds, it's gonna fail, as you can see here. Warning, unhealthy. This is the reason of why this is this is the reason why I received this warning. Let me zoom out a little bit, okay? Liveness probe failed because I can't open the healthy file, no such file or directory. It makes sense, right? Because the liveness probe was each 5 seconds was executing cat, and then all of a sudden the file is deleted. So this pod is not live anymore. Okay. So this is going to be restarted, and it's going to be restarted all over again and all over again, because that's the trait and that's the behavior of liveness probes. Okay, let's describe it again. So as you can see, the pod is restarted and restarted and so on. Okay, as you can see, it has one restart, right? And after a while, it's going to be 2, and then 3, and then 4, and all over again. Okay. So this is great. This is great for notifying Kubernetes, hey, this is not behaving correctly. This is the actually, but the reason why you want to use health checks. Okay. So here's another example with a different technique. In this case, it's using HTTP GET. So as you can see, it's using another container image, which is Liveness. Liveness is another container image that comes from Kubernetes, and it allows you precisely to test this. Okay. So this is gonna expose an endpoint, and if that HTTP GET request fails, then I'm going to receive the warning. Okay. So as you can see, this is different because I have to specify the HTTP GET field and the path of the endpoint, right? And the port number and some HTTP headers that you might want to use in your request. And again, initial delay seconds that you want to wait before starting the probe, and period seconds is the number of seconds that you want to use each time before sending the request. So again, very easy stuff. And of course, this is just for testing purposes. I mean, the Liveness container image. What would you do if you want to implement this in your applications? You need to specify and you need to implement this endpoint, right, in your microservices or containers. So, for instance, I don't know, I'm just going to use .NET Core because I happen to be a .NET user since 20 years ago. So I can do this test web API or something. I'm not going to deploy an entire web API in this moment because I need to containerize this web API, and I'm not going to use this, and I'm not going to do this because I don't have the time in this session. However, just for explanation purposes, you would need to implement a endpoint somewhere. Maybe you're using controllers, so you need to specify a HTTP GET attribute on top of those methods that you want to expose at endpoints, or maybe you're using minimal APIs, which is a new technique for creating web APIs in .NET 6 and .NET 7. So at the end of the day, you need to express and you need to deploy and implement this particular endpoint that you want to use for your Liveness probes. Okay. I hope this makes sense. Anyways, if you want to test this, you can use the Liveness container image. So this is what I had for today. In the following session, we're going to talk about config maps and secrets. Those objects allow developers and architects to use those places to store configuration keys and values or secrets. For storing your, connection strings or API keys or whatnot. It's not a very good idea to, of course, use your hard-coded strings, right? That's not a good idea. So that's why we can use config maps and secrets, and that's the topic for next session. Cool. So thank you for your time, and see you in the following session of the Kubernetes Fundamentals series.